welcome everybody to this afternoon's Driver Arts Driver event, our second today. It's definitely been a packed series covering lots of different topics. I think some of you have been along to some of our other sessions, so welcome back. And I think some of you are joining us for the first time, so very warm welcome to you if this is your first Driver Arts Driver event. So my name's Richard, and I'm the Chief Exec of Always Possible. We are a facilitation, research, mentoring, problem-solving organisation, and we've been working very closely with the University of Brighton as the events partner for the Driver Arts Driver programme for about 18 months. And I think this is event number 30 or so. So it's a real joy to be curating lots of ideas and insights about data, the role of data as an aesthetic, cultural, economic force, what we can do with it, and some of the limitations of it. And we've had some rich conversations, and I know that this afternoon is going to just add to that. Quick little bit of housekeeping. If you aren't speaking, and after me, it will be just Farhana speaking for the first hour or so. Could you please just remain on mute? Maybe dim your camera as well, just so that we can ensure that we can focus on Farhana, and then I will bring you all back in, I promise, for a conversation at the end. But you can, by all means, use the chat bar if you have a burning question or a comment or something that you'd like to add in. So Driver Arts Driver is a £1.6 million research project led by the University of Brighton, funded by the European Regional Development Fund and Arts Council England, focusing on the superfusion of technology, innovation, and creativity when using data as a tool. So the data in question is that's being used as a stimulus is the real-time data from Gatwick Airport in West Sussex. The first time that the proprietary data, and we're talking tons of data, from such a busy airport, has been made available to businesses, creatives and researchers to play around with. And alongside access to some of the data, there's also been a huge range of events, expertise, lots of research support, funding and training, which will continue until the end of December, all around this exploration of creativity and technology. Everything you need to access the rest of the programme and to find out more can be found at driverartsdriver.com. It's very much a gateway to all of the resources in the project. And if you've this is your first foray and this is your first event, make sure that you register with the site if you haven't already, so that you can access all of that. Okay, so what we've been doing with this series of online events over the last couple of weeks is considering people, places and personalisation. So the relationship between data and ourselves as consumers, thinking about the role of personalised data in marketing, in city mapping and planning, and what we do with our own personal data and the relationships that we have with kind of businesses and brands around us. I'm really delighted that our special guest this afternoon is an eminent expert in the role of data as a tool in e-commerce and machine learning. Dr. Farhana, I think there was a bit of background noise there from somebody. Dr. Farhana Liza is a senior research officer at the School of Computer Science and Electronic Engineering and the Business and Local Government Data Research Centre at the University of Essex. Research specialisms include AI, machine learning, and taking large data sets to use on predictive modelling and developing novel evaluation techniques. Absolute joy that Farhana is able to give up so much of her time this afternoon, but also her expertise and knowledge, and to take you a little bit into her world and to talk us through the impact of COVID-19 on online spending and shopping, and the kind of data infrastructure that has propped that up and what has changed in the last few months. I'm certainly looking forward to hearing what she's got to say. So once Farhana has gone through and delivered her sort of presentation to us, I'll be asking a few questions, but very much want to hear from everybody else as well. So do jot down any thoughts and questions that you've got. We'll make sure that there is time for you to ask Farhana those questions at the end. But otherwise, I'm going to quieten down now and hand over and yeah, enjoy.
Thank you, everyone. So my name is Farhana. You can call me Farhana, or if you have any question. And I would also like to know who is in the audience, like the expertise, like background. So it will be easier for me to probably interact more efficiently. Is it possible for everyone to say like your name and which organizations you're from or your background?
Hi, I've just unmuted myself. Can you hear me?
Yeah, I can hear. Yeah.
I'm Stanza. I'm an artist based in London.
All right. So you okay? Yeah. Anyone else
Want to know more?
It's fine. It's fine.
All right, I'm going to unmute myself.
All right. Is there anyone else wants to introduce? No?
A few lines in the chat there for Hannah. So Gianluca, Senior UX Designer from Arcadia, Niven's Product Designer in New York, and Meng's Product Designer in Berlin.
Nice, thank you. Anyone else? Okay, so if anyone else not interested in this, yeah, let's move forward. So today I will talk about the shopping behavior that has changed due to COVID-19 lockdown, because we are facing new normalities, and how it has impacted AI systems. Specifically, I'll talk about recommender systems. So I'm part of one of the very excellent research team. We are one of 9 research center from ESRC and Business Local Government Data Research Center. And ESRC's plan to improve research infrastructure, improve research collaboration, and the fund is a part of the bigger strategic investment. And I will first go through one of our research agenda, which is grant-funded data analytics support for organizations and businesses, for example, local government like Essex County Council, Essex Police, and also like small businesses. Then I'll go through our today's agenda, which is AI-based recommender system, how it works, some of the functionalities or algorithms that usually based on these recommender systems are actually developed. And then I will also talk about the trend that has actually changed and how we actually can cope up with this, or how we can do it very efficient way. And I will use, as a case study, I will use a lot of examples from Amazon, because they have this infrastructure for many years. And also they have developed algorithms, they have been very successful. So in many cases, I will use their examples. And then I'll see how we actually, small businesses or small organizations who actually can fit into a robust system for future. So our Business Local Government Data Research Center is funded by ESRC and University of Essex. And our core mission is to develop methodological and techniques for data science and artificial intelligence, And our objective is to improve local economic growth, also support vulnerable people through research using their data, providing them solution, what they can do with their data, and help them just to improve their system. We have been working with different organizations. Personally, I have been working with Essex County Council. They have their data science division, and so recently I have worked with their recovery plan, COVID-19 recovery plans. So how we can actually utilize the data to predict which area will be most affected, and how we can utilize resources more efficiently so that people can get best benefit out of the resources. So we have a team of researchers from social science, from computer science, AI, machine learning. We provide training. We have also provided training to, for example, Suffolk and Norfolk Police for how to use SQL, and also like how to use R for data analysis, and many other examples as such. We also provide grant-funded data analytic projects. So if you have data and then you need help to know how we can use this data, so we have this innovation voucher you can apply for, and then if it gets granted, then we can work collaboratively to see how you can find better utilization of your data sets. We also provide webinars, a workshop, channels, labs, and other marketing events. You can share, you can follow us in Twitter. And so this is the Twitter handle. So first, I will talk about what is recommender system. So when we talk about recommender system, is actually we want to more know about the e-commerce system. So traditional businesses, we have online, we have a store and we can go there, we can buy stuff, but then we have very specific, very popular items, which is on the shelf, because it's very difficult to personalize a store for each customer. So this is called long tail phenomena, where we have, which is only available in online stores, for example, Amazon, for example, Netflix, and those big organizations where, or infrastructure, where you can have both. You can have very popular items, which is shown in the blue area of the graph. And you can also have not so popular, but very niche kind of products, which is in the green line. So you can have unlimited or infinite inventory, if you want to put it in that way, which is impossible for traditional high street store, for example, who doesn't have any online presence. So this is the main advantages of having an online store or e-commerce infrastructure, and where we have to use a system, because we have infinite amount of data in product. We can't really show everything in your one page. So we have to have something which would give you a couple of items what we can buy from. But again, how you know like which customer will like what kind of items. So that's why we need a recommender system, which is a personalized store, if you want to say that way. So when we go to Google and we search something, we see something based on popularity. That's the first page. So this is the age of information. We have so many information and we can search from there. But now we are entering more into age of recommendation. So basically, we, based on the user, based on the taste of the user, we can actually display product, and we can say, okay, this user might like this kind of products. So this is the main advantages of recommender system, and this is more goes with the long-term phenomena in the graph. So what is age of recommendation? So basically, age of information, let's say we search, we have user, and we show some product. And this is based on most popular items. It's based on the whole world knowledge. And recommender system is more about, you can say like items to user, because now we can say more personalized. So this person, this demography, this locality probably would like this kind of information. So for example, in this picture, if someone likes banana, so probably, or buy banana, probably would like also buy bread, for example. So this is the information, item to item or user to user understanding is the age of recommendation. AI-based recommender system uses mainly four phases. So first, we have to know the user behavior. So collecting data. This is one thing, takes many years sometimes to get to know your customer, your clients, and collect data, understand their behavior. This behavior can be which items this customer has been buying, or what kind of test he or she likes, those kind of information. So we get this information. It's very easy actually to collect those information, because where you click, how much time you spend on certain product, and that kind of things. And then second stage is, once we have this data, we have to find out a way to store them. You can use a SQL-based system, you can use a NoSQL, you can use, depends on your data, depends on your business. That database can be different. So first collection, then we know we have to store this data. Then it comes to analysis. So once someone is looking at something, what are the other thing this customer might be interested in? What can this, based on the current thing he's spending time on looking at, what are the other items he can interested in? There are three different type of ways we can do it. One is real time, it's very fast. Another is near to real time, it takes a couple of seconds to analyze. And then another one is like, let's say, a batch system. You know your customer, you have seen what he's been looking at, and then you mail them saying, okay, you have spent some time on looking at this, or you have bought this. Now there are other items you're probably interested in. Based on all these things, all this data we have, and based on the recommendation algorithms we use, we can refine the system over the time. And then the recommendation, as we have more data, more user, more understanding of the behaviors, we can recommend more and more correct item to these customers. This last stage takes a long time. It takes a couple of years to find out a very stable recommender system. So all these things, this recommendation part and analysis part, use machine learning intensively. So for example, when we go to Amazon, I hope everyone have used Amazon or some other online system where you're searching something, then they also text about, they say, frequently bought together. So frequently bought together is being done in real time. It's very fast. It has to be instantly. When you are trying something or you have add to a cart, then someone together you want to market something which is, the similar kind of customer has bought together. Then you can also go to like more long tail behavior. That's the second row. Customer who bought this item also bought. You have like long list of items, which might not very popular, but it has like niche customer who might like these things. So that's how you increase like your way of recommending more and more product to your customer. This phase, it takes like, if it's called cold start problem. If I have just developed a system today, and if I don't have any data about a customer or item, it's very difficult to come up with such recommendation. So it requires this initial stage of collecting data, storing them effectively, and then applying algorithms, which is efficient in terms of things we are interested in. And then we come up with, over the time, it becomes really efficient. And then we see like a very relevant product come up in our search. So this personalizations. Why we need this personalization? Because it's actually have a direct impact on the businesses. So from the public information we have, is 35% purchases of Amazon are actually result of this recommender system. It's a lots of it's a big percentage of revenue actually or profit comes from recommender based on recommender system. Then Alibaba also said like 20% their conversion rate actually come from this personalized landing pages. 70% of the time people actually spend in YouTube because of they have very, very up-to-date recommender system. And also Netflix, 75% what people are watching is based on this recommendation. So we see the success of a business, it depends highly on how we are actually we are keeping our customer engaged and how we are showing relevant information, relevant product to them so that they spend more time, they buy more things, which probably they wouldn't buy it, but as you saw them, and they knew that there is a product available, they intend to buy it. So overall, what we have seen is we have a customer, number one, space is clicking different thing, and all this information are actually, we stored them, we keep them in a database in in step 2. Then we use this in our recommendation engine. It has this tracker, it has these algorithms, it has different user informations, different ways to measure similarities. And then we provide this recommendation to this user based on what we have been doing so far. So how many types of recommender system we have? In general, very popular recommender system is collaborative or social filtering system. And then another one, which is like, which was more, is more old, which is content-based system. And then we have different variations like item-to-item collaboration, hybrid model, which use both like content-based and collaborative filtering system, have cluster model, knowledge-based system. Today, we will talk a little bit more about the first two. So what is the difference? Okay, so far, if you have any question, you can ask me, or if you don't have any question, then I can go on. Is there any question from audience? I guess no.
Nothing at the moment, I don't think.
Okay, thank you. So type of recommendation, we can use two main type. One is content filtering. So as I'm showing in this right-hand side of the picture, let's say a customer has bought a blue dress and red bag. So recommender system have this information collected that this customer has liked and bought this kind of features of the dress and this kind of features of the bag, red color probably, but it is like certain type of bags. The recommender system, the content-based one, would actually recommend similar kind of dress, probably in different color or different design, and similar kind of bag to the same customer because it has this information that this customer usually likes this. And then there is the problem with this system because as you can see, it's very specific, customer specific. So we have to information about this customer, their previous purchase. And if there's a new customer, we can't really say what she or he is gonna like. So this problem requires like understanding feature of the product, understanding profile of the customer, which is usually quite difficult. And then we have another type, which is collaborative filtering, which is more social filtering, I would say. So it's actually try to match behavior of customers. So if I have a customer who liked and bought, for example, this dress and bag, and then I have another customer who also buy and bought before similar kind of dress and bags, Now, if one customer is trying to buy another dress, then I can assume, okay, probably the similar customer would buy the same thing. So it's like if two customers agreed on products before, then it is likely that they will agree in future too. And this is very, very successful approach for recommendation. Netflix has been using it for after there is this algorithm actually come up as a competition. They released a data set and they wanted to find out the best recommender system, and this algorithm came up, and since then they're using it. So it's quite, and there are many other organizations who are using collaborative filtering. It's very useful because if you have data, even if you have less amount of data, it's not really user specific, it's more about social understanding. So it works quite robustly. But again, it takes time, it requires data. It's not like you can actually start it without any data. So what is the problem with collaborative filtering system? Like why it is so challenging? So if we look at traditional machine learning system, we have some training data, we have some testing data. So what we want to do is we have this dependent variable, let's say rating of a customer, how one product will be rated by a customer. And independent variable can be many different things. So we can just write a logistic regression or some kind of regression algorithm to find out what would be the rating for this dependent variable. But the collaborative filtering or any recommender system is not that structured. It is more like the right-hand side matrix. So we have many missing values. We don't know, and we are unknown. So we have to fill them up in some way, meaningfully and efficiently, so that we can actually find out the ratings. So what does that mean? For example, we want to fill up this left-hand side matrix, which is saying in user A, how he or she would rate item X. We have, for example, some data saying, okay, user A will like item X for 4.5 out of 5. We have information about item Y as well, but we don't know anything about item Z. We have four users, user A, B, C, D, and they have provided different information about different ratings about the items. So how we can do it efficiently so that we can predict if user A would actually like item Z. So this is where it comes, this data, this representation, how we can store it, how we can know like how similar a user with another user. So this is called user metrics and let's say item metrics. What it does is it gives some kind of representation. So we represent user A, let's say with 2 columns, 1.2 and 0.8. Let's say these columns can be something telling about this user characteristics. That user likes red bags. This user likes, for example, blue dresses. And this kind of numbering can be generated using AI systems. One of the systems we can use is neural network, deep learning methods. There are many other ways we can come up with. And then we have information about the items, which is also saying something about these item features. By utilizing these two, we can actually predict what would be the rating of Z. So very naive basis, for example, in this example, we have similar attributes for item X and item Z. We also have very similar customer, for example, A and D, because A score are 1.2 and 0.8. D score is also 1.2 and 0.8. So we are saying A and D are quite similar customer. Then we can look at this this metrics, the bigger rating metrics, and we can have a look at these customers, what he has actually rated for item Z, which is 1, which is not that good. As A and D are quite similar customer, and they have quite similar choices for X item, which is 4.5 and 3.5. So we can assume probably customer A would not like that much this item Z. So because the user D has rated only 1 for item Z. So this kind of prediction, this kind of filling the missing elements of the matrix is being done and using the collaborative filtering system. So the one I have just described, this is called user-based collaborating system. There can be other variation, for example, item-to-item collaborative system, which is being used by Amazon. It depends on what information you have more. Do you have more information about your user, your customers, or do you have more information about items? So if you have a very large business and you have so many items and you have been so many ratings for each item, so probably item-to-item collaboration is the better approach than user-based collaboration. So it depends on data, it depends on business logic, and so on. So what happens for example, item-to-item collaboration? So instead of looking at, in this one, looking at the user similarity, we would look at the item similarity in the rating matrix, how that item has been rated, and then we would find a prediction for the missing value. So in general, it sounds like it's quite very technical, but actually it has real-time understanding and meaning, and it is easy to understand. But what it makes it difficult is to set up a system like this. The main challenge is coming from the collecting data. It takes a long time. It takes an infrastructure which can be quite expensive, and it also takes a long-term commitment in terms of economic and social perspective. As this system can be wrong, so there are some social challenges as well. So there are many stories you can read. There are blogs where Amazon made mistakes, and there are lots of criticism they had to go through. Google make mistake, and they also has to go through different racial comments and other stuff. So there can be social challenges to having a recommender system, and also maintenance. It can be quite challenging to have a server to keep it running, to make it sustainable. So there are some general consideration for recommender system. So it makes I will answer this question later. So if it is so difficult, then how come a new organization, a small scale organization, can actually afford such a system? And how can actually they see, like, is it possible to get a recommender system for my online presence, and is it really sustainable? So yeah, I will discuss this later on, but in general, it's quite difficult. So before I go more about this user behaviors and stuff, is there any question from the recommender system in general, the algorithm?
Don't think so, Farhana.
Okay, thank you. So what actually most important for us, what makes us actually click add to cart? So if I took it from Think with Google. So they have this data and they had been doing this analysis. So for example, what is most important for British customer? How they decide, like, when they buy online. So first is, if you look at the right hand side, most influential factors is like lowest price has to be low, it has to be, they prefer free shipping, sale discount, product specification, if it is a large or large hard goods, for example, devices and so on, then product specification. If it is this product is available or not, or if it is like, is it on stock, and those kind of things are more influential rather than, let's say, how it is popular in social media. We don't really care about those things. So then if it is comes to soft goods, for example, clothing and beauty products and those kind of things, again, the price, fast delivery, free shipping, these are the things actually more influential for a already existing customer who buy from online store. And if it is for everyday essential, again, the trend actually quite similar. So for British customer, it is really important to get delivery on time, fast delivery. Of course, the price has to be reasonable, but after this, delivery is quite important. And having product in store, these are the things we prefer. We also prefer to repeat visit the same kind of store, same because it's kind of trust issues, I would say. So if we buy something, we get good product, we are happy with this, then we purchase from the same store. During the lockdown, what happens at the beginning? Because we were not really ready for such situation. So a lot of customer actually suddenly become online customer. And the store, they don't really have this prediction beforehand that there will be such a big demand for certain products. So delivery got really delayed. And then also the recommendation, because the recommender system, as I told you before, we need lots of data. We need to have them stored in some way so that we can use it in the algorithms. But as new customer came in or new product came in due to lockdown, for example, we suddenly started buying toilet rolls in a huge amounts. This was not a common pattern. So the algorithm actually was not really working very efficiently. These two things, this increase in data volume, because of this increased online purchase, and also because of change of behavior, like some customer never bought online, but they just get registered and start buying from there because it's just situation was like that. The recommender system had to change and adapt the patterns and all this increased amount of data and users and everything. So this is called in computer science language a scalability problem. So if you have something which is you are designed for 50 customers and it works for 50 customers very efficiently, but then suddenly if the size of the customer has become 5,000, then your system is not really working as expected. So Amazon Personalized has actually had to adapt it during this lockdown because they have lots of small businesses who actually can use their infrastructure for their recommender system, for their online presence. But as this is increased volume of data, increased volume of user activities, the system was not really working. So what they have done is within around 2 months of time, they change their infrastructure to completely serverless. So what does that mean? So we have different type of infrastructure, right? So we have these traditional, let's say, our own infrastructure where we have, we call virtual infrastructure. And then we have this container-based system. Container, for example, Google Container-based. Then we have platform as a service. Function as a service is what we are calling serverless. So function as a service, we don't really have to worry. It doesn't mean we don't have a server. We definitely have a server, which can increase scalability on demand. We don't have to worry about anything. All we have to worry about the business logic. And it's an event driven. So when we need serverless is when we want to extend service in a fast manner without investing a lot of time and a lot of research and a lot of risk analysis. If a business just want to go online, you want to just start selling and getting users and customers online, then this is one of the way we can do it. And this is what actually Amazon did for their own underlying infrastructure. So this has actually changed so many things, because initially we can, businesses could think just to have, let's say, a brick and mortar, just a high street store, don't have to think too much about, let's say, how we are going to sell if the store is closed. This is a new thing. So incorporating AI-based e-commerce in the point of sale, probably one of the thing is going to happen post-lockdown time. So we can have, the good thing is we can have new sales channels, because before we used to have just one type of selling, online based. We have this point of sale, and you can go there, you can buy, you have cashiers, and you have customer service. But as these things are changing a little bit, so people are now more inclined to buy online. And this new way of selling, e-commerce based, would be probably a new thing for many businesses. Cloud-based customizable, the one I just said, the serverless infrastructure. If I have a business which is not that risky, and I can just have it, like I want it in 1 month time to have an online presence, probably one of the way we can do it using those infrastructure. Google, Amazon, and different other organizations have expertise, and it's very easy, actually. It's quite cheap compared to the traditional one. And then cashierless or staffless store, for example, Amazon has already done this. You can go in, you can put your stuff in your stuff in your cart, and then when you when you are exiting from the store, it's actually automatically take the money out from your cart. So that's kind of thing that was already done. Probably it would be more, because this social distancing and those restrictions are being imposed. So it probably would be more practical for many businesses. Demand forecasting is one thing. It's very good. Artificial intelligence based system can do, and machine learning based forecasting has been there. So I have worked with Essex County Council to forecast like the demand of different areas based on the resource we have, where we should invest these resources more effectively. And there are different ways we can do time series analysis. We have different machine learning based approaches. So this could be one of the things probably be more trendy after post-lockdown. And augmented shopping, for example, we go to shop in a store to buy stuff because we want to try them before we buy it. But if everything become online, how would we know actually how this dress would fit on me? So this augmented shopping has been, it's not that new, but it's quite new. So what it does is you can put the type of your ethnicity, you can put your size, the type of model, and then you can see the dress, how it looked like. And then you can actually make more informed decision based on these. And deep learning models has been used in these situations for many different reasons, because image-based system, for example, convolutional neural networks, is very good at find the trend, find how it can be augmented in a very efficient way. And then you can change your background to see like how this dress would look like in certain background, in a white background, in outside, or in a light or in a dimmed one. So different ways you can see. So this is very, very popular these days. And I think if with an e-commerce system, it could be a very good accessory. I mean, to have this, to see how it looked like. it would help this organization to businesses to just sell more effectively and recommend more effectively. So this is so far, this is what I wanted to say about different behaviors and how we can transition, how we can actually make it more feel like a normal store, and how we can like basically thrive even in a COVID situation, COVID lockdown situation. So my team, we are also doing other webinars. So one is actually tomorrow, open source data, how and why we can use it and how it is useful, and how visualization of data can be done, and social return on investment. So these are different dates, and if you're interested, I would recommend to register online to get more about those opportunities. And also there is coming up a bounce back from COVID-19, how to evaluate times of social distancing, and like how we can explore text data. So this is one of my area of expertise. I work with natural language processing. So if you have textual data, you want to know more, you want to extract information, you want to know, for example, how you can extract event, how you can extract knowledge, certain particular knowledge from this text data, we can help. Our team are very good at those areas. So this is what we do, grant funded. If you have problem, you have data, you don't know how to solve this problem with this data, you can apply for grant funded data analytic projects. We also work with collaborative projects, research projects specifically. So if you have a research team and you want to collaborate with us, we are really open for fundamental and applied sort of research. We also do workshops, podcasts and webinars, and provide training if you need it. We have done before different technical and also like social science based training, and you are most welcome to apply for one of these. If you have any question, let us know. You can. It will be really nice if you can share and connect with us in Twitter, LinkedIn, and YouTube channels. And thank you very much for your time. If you have any question, I'm really open for all interesting questions.
Thank you, Farhana. Really interesting insight into the back end of how all this works. I'm one of those slightly naive people who thinks either it's just a bit of magic or it's just, you know, it's very clever, but it looks like a lot of science has gone into thinking around how this works. So opportunity for people who are zooming in to ask questions. Please put something in the chat bar, or put your camera back on and kind of raise your hand, and I'll bring you back in. But I wanted to know, particularly, you know, the examples you gave, really fascinating, and I think people will be familiar with obviously some of the big online retailers that you mentioned. But you also kind of hinted that because of lockdown, a lot of smaller businesses have rapidly sought to get an online presence and to become e-commerce providers when perhaps they hadn't done that before. How accessible is all of this for small businesses? I quote, at one point you said that to have a kind of stable recommender system, it takes a couple of years. Well, what have people been able to do in a couple of months, and how personalised do you think small businesses are able to get their e-commerce platforms in any kind of effective way? Yeah,
I think that's the main. It's a challenging, but if the data and if the product we're selling is not very sensitive, it doesn't really. Let's say if I'm selling cake, or if I'm selling something which is, or I'm selling clothes, and I had only a real I didn't have an online presence and I want to get one, most easiest is to get one of those providers. For example, we have Amazon, we have Google and other cloud services, which actually is very easier to get on in 1 or 2 month time. And then when you have these things, you see it actually working. You have online customer and your customer actually really happy to go online and buy your stuff from there. Then probably you can think about like more longer term replacement of having a more stable infrastructure. But I think initially is Amazon Personalized is one of the way we can just move forward because it's easy. They have 20 years of data. 20 years of data is lots of data. I mean, and they actually sell those data in terms of providing better recommendation through their algorithms. But they charge you, but still it is much more cheaper than if you go for example, developing your own infrastructure, developing your own security system, and doing everything from scratch.
I was quite surprised by in that fascinating graphic you showed of what UK customers find important, you know, and clearly fast delivery and free delivery and price outstripped everything else. I was quite surprised at how low down customer reviews were, and I think if ever if you sell anything online, the mantra is always get as many reviews, recommendations as you can, whether you're selling something on eBay, whether you've got your own shop, or whether you've got a podcast or whatever, because the algorithms love it. You know, if you want to get up on the top of the list, it's the only thing you can really control in terms of the algorithms is to get all your customers to say how brilliant you are. But your graph showed that that's kind of not that important, is it?
Yeah, I think it's not important for customer to look at the the reviews and stuff, because I think they really trust those for example, they trust Amazon. When you search something and it gives you, for example, the first couple of them, and you just look at this 5-star, you automatically know there are actually good reviews. You don't really go individually what are those reviews are. It's just my guess because this is from the Google data. So this is based on Google data. So probably for them, what they have seen, it's not that important, but it's probably with some very tiny, minor, tiny measures, is not that big difference.
So what value is all this to the customer then, truly? I mean, I get that this is, if you're going to run an online shop and you want people to buy the things you want them to buy, then this process and the Rexis is undeniably the thing to do. There's a reason why Amazon make as much money as they do, because they are able to make you buy things that you didn't come in for, just like the big supermarkets. But okay, as a customer, on the surface, I can see how useful it is, and I probably do buy things that I didn't come in for. But is there a real benefit to the customer here? Has there been any studies to show that we're actually better off as consumers because of kind of personalised recommender systems? Do we feel better about the world and what we're buying and how we're shopping, or really is this a con trick just so that the retailers can sell more?
I think it's also for us when we go to an online store and when we find something which is very relevant, we find it is kind of, I think, amusing. Oh, okay, I didn't know that I like it. So I think this is one of the probably the people who really buy very frequently from Amazon, from let's say other online store. They become really kind of rely upon this recommender system without knowing that their data has been used, their likings has been used to improve this page that I'm seeing now. And they kind of start having a trust on the system rather than, that's what I say, they look at this 5-star how many star it has, 4.5, but they don't really go look into each and every reviews. Probably there are 10 reviews saying this product is really bad, but there are probably 1,000 reviews are saying is really good. So it becomes 4.5 anyway. So instead of going through each reviews, we just, okay, there are 4.5 star and it's quite relevant what I like. So just go for it. So I think it's kind of, over the years, we have this kind of tendency to liking the systems, and now we just go for it.
And how far is this recommender system and personalisation coming off the online space and into our other spaces, do you think? I'm thinking of some of the Black Mirror episodes in which, our entire lives are dictated by the data we've put out, and some algorithm reflects back to us about our choices in relationships and about our choices in, and I'm sure these sort of algorithms are in play when people are using online dating sites. There's more decisions that we are trusting personalized algorithms to help us make beyond just the groceries we buy or the things from Amazon. It's helping us choose what music we listen to. It's helping us choose our partners. It's helping us pick our mortgage providers. Is there an end? Is there a point in which that stops, or will it, do you think, ultimately come into every part of decision making at some point?
It's very difficult, actually. I mean, I think the way we are more relying on online, our life has become more dependent on the online shopping. Online, we spend lots of time on searching stuff in Google. We watch movies in Netflix. We listen music or watch stuff in YouTube. So we are kind of evolving with those recommender system or with the systems who uses our data, make it more personalized. It becomes kind of they know us for sort of things, like these systems knows us, like what we like. So there definitely, I think there are probably bad impact of it, or there are probably ways we can get used by those systems, but I don't really know. I mean, probably there are some research that I don't know.
Yeah, well, it's probably more of a philosophical question, I guess.
Yeah.
At what point does it stop our free will and our free choices determining the thing that we are recommended, versus actually, ultimately, we are only making decisions based on algorithmic recommendations. So therefore, who are we? The things we get recommended in 10 years' time are based on 10 years of us being told what to buy. I'm not expecting you to answer that, but there's a huge wealth of existential questioning about personalization, isn't there?
Yeah, I agree.
I'd love to bring in some anybody else if you want to ask Farhana a question, whether it's a technical one about how the systems works or a broader one around e-commerce. Gianluca, Livan, Nirmal, Nigel, you're very welcome to come in if you want to. So a question there in the chat from Niven, thank you. Is this the same as agent-based modeling?
There are some system which is reinforcement-based. There are different algorithms which get information. The algorithm can utilize agent-based modeling, but it's a separate thing. I mean, if I want to keep the recommender system, is one thing, and agent-based modeling is another thing. But agent modeling can be incorporated in recommender system if you want to make it more. If you want to incorporate robotics, you want to incorporate more user feedback. So that I don't include in this presentation. It's called implicit feedback incorporation. or explicit feedback incorporation, where you also utilize your negative feedback, negative reviews you have, or for example, return, if someone returned a product after buying it or said very bad about it. So those things are when you want to incorporate in your recommender system, you start using agent-based modeling. So yeah, it's not exactly the same, but it can be incorporated.
The systems that you showed rely on that kind of feedback loop, that kind of user generated decision making, which then gets interpreted, as we go along. Do you have any examples where you've used a kind of recommender system from a huge kind of data dump, maybe a historical data dump, so where there's been years and years of behavior mapped or decisions made that's put into a system, and then that kind of then creates a whole set of recommendation going forward based on that? Have you done that before?
Yeah, so these are, when we say like behavior, the easiest one is done is, let's say, your online activities. So where you click, how much time you spend on certain product, how you have interacted. Did you click 4 times, spend 5 minutes, and then did you buy it or you just walk away? So these are like behavioral information you try to capture, and then you match this with other users. So you have one user who has done similar things and bought ultimately, another user has done similar things and bought ultimately. So you get like similar kind of user profile. You match this with the item they have bought, what the profile of that items, and incorporate them. Then these are the information who has been done traditionally. Recently, we have even more because we have more technical capacity. Now we can use, for example, 16 gigabyte of RAM, which was impossible in 10 years ago. So now we can have like more bigger algorithm, the algorithm which is more complex, we can use them. Now we can incorporate, for example, user feedback, their reviews, their the return history, why they have returned, all those information, because main intention is to profiling 2 things. One is to profiling the customer, another is to profiling the product we have. So for these, there are different techniques. It depends on how much resources I have. So that's like a transitioning. It's last couple of years, but it's a new thing. Yeah.
Mm. And are there any, and I know it's a kind of different sphere of research, but obviously recent elections are in our minds. And, whilst that's in many ways a different sort of analysis of personalised data choices through, opinion polling and stuff like that, what we've seen is obviously how certain companies have mimicked the kind of e-commerce platforms in order to get people to make decisions about what it is that they like or don't like, clicking on particular fake news stories or provocations, so that they can build a data set that then recommends back out, the shortest pathway to voting for whichever candidate they want you to vote for. Do you, is that a completely different system, or actually are there lots within the e-commerce kind of Rexis setup that's mirrored in some of the slightly more nefarious political game playing?
Yes, I would say, okay, you can use your recommender system. That's what I was trying to say. So once you have this profile of your customer, or is it ultimately a person, right? And you have information about their demography, you have information about other stuff, you can misuse this data. You can use this data in a different way. So these 2 different things. There are lots of regulation and legal stuff has been people are discussing, and regulation has been probably would come in place in coming years. But right now there are very, very there are not enough regularities which actually can protect these organizations, or they have this data already. So they can, to answer your question, they can actually use this data, just not for e-commerce, probably for other purposes. We don't really have a law, or we don't really have a way, actually, I would say. Probably we have a law, but we don't have a way to impose this law, because we don't really know what kind of information already they have and what they have been storing us. So for one of these things like Alexa-like systems, and those have many security concern, but still people are using it after even knowing that their conversation has been stored there, but still people they want this convenience. So how this data is going to use, that's a different story, and how it's going to be, that's would be another discussion probably.
Yeah, I'm surprised how quickly we've kind of accepted that, you know, we have a phone conversation with a friend talking about, you know, particular, you know, foot cream or something, and then lo and behold, that's what you're being advertised on Facebook without having pressed a button.
Yeah, exactly. Yeah, there is one of the I was reading one of this blog where one couple, they've been talking about going to a vacation in some place, and they are talking about how they're going to book it, and in a couple of seconds they got a recommendation of which travel agent they should use and how cheap that one. So this is a kind of thing we don't want, but we know somehow that our information has been used in a.
You say we don't want. Who doesn't want? I mean, in a kind of regulatory Wild West, you know.
Yeah, I would say like, yeah, people somehow, I don't know, how I would personally wouldn't like it. Like, I didn't want Alexa to listen this and just recommend it, because I didn't ask it to listen. But anyway.
Until it's really useful, I guess. Nigel's put a question in the chat bar. Do chatbot interactions influence recommender systems?
Yes, it does. So all these interactions are actually if we give our consent to be saved, so they are actually stored in databases, and then they are used for improving the system. So for example, in Alexa is a kind of a chatbot. So you can actually, it asks you to, if you want them to store the data, you can give the consent or not, but these data are somehow stored, and then they use it to improve, for example, voice recognition, to improve your question answering. If you ask your Alexa for a question, so it wants to improve the system, but to improve the system, the data has to be stored. And it's not really known like what kind of data they store and what they don't. So yeah, but that can be used to improve recommender or influence recommender system.
Thank you. Good question, Nigel. Okay. Any other questions before we conclude? Thank you, Dr. Farhana. That was really interesting. Yeah, it's a world I know very little about, but I'm fascinated in, because it certainly impacts me day to day. But in terms of the wider DRIVA project, lots of really interesting pieces of research happening around, you know, taking elements of personalisation, and you know, some people have used that as a stimulus for a kind of creative project and looking at art pieces as a response, and others looking through, you know, kind of collaborative tech developments on how you could take something like the Gatwick Airport data, which has been a fascinating year to look at that, because obviously very, very, very high, and then suddenly dropped enormously. So in a way frustrating, but also you can start to see how the behaviours of the way an airport moves and operates can actually throw up some interesting insights that may, you know, that could actually inform a recommender system for the future. So yeah, really interesting stuff. Thank you. So We've got a couple more events coming up in the near future that I'd like to draw people's attention to. Just get my screen back up. So there is one tomorrow morning, which is all about the city of Brighton and Hove. Brighton and Hove, very much driven by the tourism economy. And what they've realised is just how much, how valuable the data on the way people move, where they go, what happens when they come in, is for making forecasts about the city's recovery plan. So Gavin Stewart, who is the Chief Exec of the Brighton Business Improvement District and the Economic Board, will talk very candidly about the data that they have been collecting and how they've been using that to kind of forecast and make decisions about economic emergencies, but also what they don't have. And actually, if they could design a way of mapping and collecting data on the sort of choices people made in a city like Brighton and Hove, so to help future investment, what that might look like. So I think it'll be a really fascinating conversation, and Gavin will be in conversation with Bonamy Waddell, who is a data insights expert as well. So that's tomorrow morning at 9:30. We do have a few spaces left if you'd like to join. And then in the afternoon on the 8th, on Thursday, we have Gillian Kowalchuk, international speaker and entrepreneur, doing lots of work around female entrepreneurs with the UN and so on. She is the founder of Safe in the City, which is a data-driven app that is kind of crowdsources data for people who walk around London, particularly women, and that crowdsourced data has sort of mapped the city intricately to create a kind of a live heat map of where is safe and where isn't safe, and using user experiences to give insight to others about where is well lit and where is where is a safe route to walk at night on your own, that sort of stuff. And it's a really fascinating project that's turned into, like I said, a very popular app. So Gillian will be talking about the genesis of that, how that came about, but also the technology behind it and her role as a kind of data-driven entrepreneur and what the implications of that are. So really recommend that people come and join that, which is on Thursday at 3:30. All of the tickets for this can be booked through driverartsdriver.com/events. And you can also find the webinars of previous events that we've done in this series. And I think if you've enjoyed Farhana's talk today, you will enjoy a session that we had a couple of weeks ago from Dr. Alistair Good from Gorilla in the Room, who are a market research and insights company using immersive technology like virtual reality and augmented reality to predict consumer behavior. So they get commissioned by lots of big retailers to use simulated shopping experiences to try and work out consumer behavior. And he gave a very interesting sort of illustration into the psychology of shopping and how that has started to change with the rise of online. So do check that out. The full recording of that is available. And like I said before, please play around with the driverartsdriver.com site, find resources and research, and also if you take part in at least 12 hours of events, you can apply for some funding. So there is an open call for what they're calling the Superfused Awards. So if you've got a project or an idea that you'd like to develop based around data and innovation, then you may be eligible to apply for that funding, which closes at the end of October. So please do check that out. But until we see you next, which I hope will be tomorrow morning, then have a very pleasant evening.